Well, good morning, everybody. It's a nice rainy day here in the land of enchantment. Today I want to talk about the flat Earth distance to the sun. What if I, as somebody that believes in a spherical Earth, were to calculate the distances to the flat Earth sun? What will that prove? I think you're going to be shocked. The joke of the week: people call me ugly until they find out how much money I make. So the book on Zetetic Astronomy, if you guys want some hilarity in your reading, this quotes here came from the Flat Earth Society. Thomas Winship, the author of Zetetic Cosmogony, provides a calculation demonstrating that the sun can be computed to be relatively close to the Earth's surface if one assumes that the Earth is flat and that light travels in straight lines. This is a quote from Mr. Winship. On March 21, 22, the sun is directly overhead at the equator and appears 45 degrees above the horizon at 45 degrees north and south latitude. This, of course, is the spring equinox in the northern hemisphere. As the angle of the sun above the Earth at the equator is 90 degrees, while it's 45 degrees at the 45 degrees north or south latitude, it follows that the angle at the sun between the vertical from the horizon and the line from the observers at 45 degrees north and south must also be 45 degrees. The result here is two right-angled triangles with legs of equal length. The distance between the equator and the points at 45 degrees north or south is approximately 3,000 miles. Ergo, the sun would be at an equal distance above the equator. And you can look at the Flat Earth Society's website to see this quote. So let me show you the isosceles triangle he's talking about here. So here we have this triangle. You can see the right angle at the equator that he talked about, the 45 degree latitude over here, and it makes a 45 degree angle to the sun where you see the sun. So this is the triangle that he's talking about. When he talks about two triangles, he's talking about a mirror image triangle for the southern hemisphere. So Zetetic Astronomy used only the 45 degree latitude because it gives this isosceles triangle here, so that the baseline is equal to the height. Therefore, the sun height is equal to the distance from the equator to the 45th parallel, which happens to be 3,110 miles. What you really have, though, is the good old opposite over adjacent from trigonometry. So does anybody remember what that's equal to? Anybody? I'll give you a second here to think about it. Opposite over adjacent. What is that equal to? So opposite over adjacent is equal to the tangent of the angle between the hypotenuse and the base. So here it's that 45 degrees. So if we do a little rearranging of our terms here, because we want to find the height of the sun, we have opposite side is equal to the adjacent side times the tangent of the angle. So what you really have is a very simple equation. The opposite side, which is the height of the sun, is equal to the adjacent side, which is of course the distance from the equator, and multiply that by the tangent of the angle, and the angle here is in degrees. So let me show you my data here. I went to Excel, I entered the latitude, and I started at 0.2 miles, or 0.2 degrees, I'm sorry. And the reason I did that is because at 0, the tangent does funny things. So I started close to the equator. And then I did every 5 degrees all the way up to close to 90, which again, the tangent does crazy things at 90. I calculated the distance from the equator. If you look that up, each degree of latitude is equal to 69.1 miles. So you can easily calculate that distance from the equator. The height of the sun then is going to be that equation we just saw on the previous slide, would be the tangent of the latitude times the distance from the equator, and that gives you the height of the sun. So then once I calculated those, I wanted to see a graph. Here is my graph on the right, and you can see that at the equator, or close to the equator, we have 4,000 miles. This again looks like a asymptote. It's reaching 4,000. It's not going to go higher than 4,000. So then at the pole, it's about 6,000 miles from the equator. You can see that the distance to the sun at the pole is 315 miles, which we can round off to 300 miles just for rounding. Then you notice I put in here a label where the point is that the Zetetic Astronomy book used, 3109.5, which rounds to 3110. And you can see that that is at the 45-degree angle, and it's basically halfway above that, or along that curve. So here we have a distance from the or a distance or height of the sun, and you can see that this height of the sun, it changes based on how far you are from the equator. So my conclusions from this graph, I didn't do any statistics, no curve fitting, no smoothing, no trend line. Those are just the plotted points at every 5 degrees of latitude. The 3109.5 is the 45-degree Zetetic Astronomy number calculated using the tangent. So I did my own calculation rather than rely on his isosceles triangle. The southern hemisphere looks exactly the same except mirrored around the height of the sun axis, which I'll show you in a minute. At that, when you see the two triangles together, what you'll see is a parabola with its vertex at the equator and the apparent sun at 4,000 miles high, opening downward. The parabola ends at the North Pole and the South Pole, or the South, whatever you want to call it down there, and the apparent sun at 315 miles. Note that this parabola is at one apparent sun location at one instant in time. We didn't look at the change in the sun distance as you move around the Earth. So if you were to extend time over one day on a flat Earth, you're going to have some kind of circular donut shape, except flat on the bottom and not touching the surface. So we, those of us that question observable reality, have to ask ourselves, why is this a curve, a parabola? Why the two constant numbers at every longitude? 315 miles at the pole and 4,000 miles high at the equator. Why is that? So here I want to show you the double curve. So this shows the distance from the equator, both to the North Pole, that's the positive numbers, to the South Pole is the negative numbers, and you see the parabola there. Then I also wanted to show you the thing on its side, because the equator we know is sort of a horizontal line, and so I wanted to show you this parabola on its side, and you'll see why in just a minute. Again, I'm questioning why does this occur? What exactly causes this? So I begin to search for any physical reason for this parabola shape. The 350 miles at the poles and the 4,000 miles at the equator. Interestingly, as I searched, the atmosphere extends to approximately 300 miles. This I took from space.com. And even more interesting is that the inner Van Allen belt extends from the edge of the atmosphere to approximately 4,000 miles. This I took from Seattle PI. So the seriously amazing fact follows on the next slide. So every one of you better hang on to your hat, hang on to your seat, or hang on to your socks, whichever you might want to do. Here's the picture. Notice this inner Van Allen belt over here, and how much it looks like that parabola on its side. There it is. So it extends from 300 miles over the surface of the Earth, and then its vertex is at 4,000, and then extends at the North Pole to 315 again. So that's pretty amazing, I think. So what do I see when I look at that as a believer in the spherical Earth, I see at the end near the poles that the height is at the upper atmosphere. I see in the center at the equator its height or vertex has to be at 4,000 miles. Its shape of the Van Allen belt, inner Van Allen belt, is a parabola. So, and as this parabola circles the Earth, it creates a donut shape. Very amazing, I think. There is some effect of the inner Van Allen belt on the apparent height of the sun, possibly due to the high electrical potential in the Van Allen belt. The visible size of the sun and surface features are unaffected and are caused by angular size. So you're still going to see the sunspots and flares and corona, all those things, because they're all affected the same way. This, however, does not affect the size of the sun, the distance, the composition of the actual sun, planets, or stars. It doesn't change the fact that the Earth rotates. All it does is show that there's some kind of interaction between the apparent height of the sun and the Van Allen belts. So my weekly joke, people call me ugly until they find out how much money I make. Then they call me poor and ugly.